This is the 6th lecture of the Python beginner course, and today we're talking about classes. So let's get right to it. So technically classes come from the idea of object-oriented programming, which means that a class represents an object, like an employee or like a car. And that car can do some things. It can drive, it can stop, it can turn on the lights, it can honk, and all of those things that I have just mentioned are actually methods that the class can do. Let's go and dive into how to actually implement a class in Python. So classes are written with the word class, and then followed by the name of the class. So I'm going to call my class new car. Or you know what, let's call it car. And then followed with a colon. Now, a class is actually a template for an object. So you can either have a class that is all static, which means that no objects are created and you use the class as is in every piece of code, or you are designing it to be able to create objects that each of those objects can do all of the functions that you design in this class. So for example, a car is something that has multiple functions and owned by a multitude of people. So you expect that this class would be creating instances. There won't be just one car that everybody uses. There would be a car for each person. So in order to create instances from the class, you need to define a function called init. So as we learned in the last lecture, you define functions with the word def. So let's def, and then I'm going to start writing init, and you can see that Visual Studio Code is already giving me the option to autocomplete. So I'm just going to hit enter, and you can see that it already created the function for me. So what do we do with this now? So let's say when I create a new car, I can give it a license, and that license is going to be a string. So what I just did here, which I didn't mention in the previous lecture, is typing. What type of argument are we expecting to receive? And here I'm expecting to receive a license, a string. So instead of passing, by the way, pass is a command that says don't do anything, just pass this clause of code. This piece of code will not do anything. So now instead of doing this, I am now going to take the license that I got and save it within the instance that I have. So if I do self, which is my reference to myself, or my reference to the object and not the class itself, I'm going to write self.license and then equals license. And here we go. So if we are going to just stay with this for now and not do anything else, let's see what we have. I'm going to create a new object. Let's say my car equals car, and there you go. Visual Studio Code already tells me what it expects to receive. So here we go. I'm going to give it 1, 2, 3, 4, 5, 6, 7, 8. Doesn't matter what it is. And then I'm going to print my car.license and see what we get. So let's play as we always do, run and debug, and here we go. Now if I have your car equals car and 2, 3, 4, 5, 6, 7, 8, 9, and I do this again, so if I run this again, we can see that we got two different prints here. And mind you, this is just one piece of code. So for now, we already know that classes provide reusable code, which is an immensely powerful thing that every programming language probably has. Not all of them, but many of them already has that. And it's important for you as an aspiring programmer, a developer, software engineer, to think about not putting code in your program that is duplicated. You want to have just one source of truth. So if there's one piece of code that can do something, only that piece of code should be used around your program. So for now we have the class car, and we already know about creating an instance of that car, of that class. So now let's add another method, which is not just the init, which is for creating. We're going to actually do another method here. So let's say is driving, and I don't need anything, but I do want to receive back a bool, which means I'm looking for either, I do need to write self in here, and I do want to know if I am driving right now, if the car is driving right now or not. So self dot driving, return self.driving, and self.driving doesn't exist, so we are going to add it here. Self.driving equals false, because a car that was just created isn't driving yet. So we now have is driving, and we're going to also create def drive self, and I'm not going to ask for anything back, and I'm just going to change self.driving to true. And another one, def park self. I'm really glad that I went with the car example, because it's really easy to visualize every method that I need to write here. Driving equals false. So let's try it out. We now have a few methods here, and let's see. So I'm going to get rid of those two, and let's print, first of all, just to show that my car dot driving is false, and then my car dot drive, and we're going to call it, and then let's print it again. My car dot driving. So what we're doing here is we are printing first that the car is whether the car is driving or not, and we expect to receive false, and then we're going to initiate the drive method, which would change driving to true, and then we're going to print that member or property, just to see that the car is actually driving. So let's try it out. Let's save, then run and debug. We have false and we have true. So there you have it. Now also let's add my car.park, just so I feel good with myself about writing this little method. My car.park, no, my car.driving. And let's do it again. False, true, false. Great. This was the most basic explanation of classes in Python, but I do have two more things to show you. There are different kinds of methods in the actual Python implementation of classes. So there is something called annotations. You can describe what is the kind of method that you're using. If I want to do a class method, I will do this. And this is the annotation that tells Python that the isDriving method is actually a class method. And now what that means is that I don't need to define this method in every other class that may use this implementation, which is called inheritance. So for example, I can do another class here, and I can call it Mercedes. And Mercedes can inherit from car. And this is how we determine inheritance. We just write this one here. We write the name of the class we're inheriting from in the parentheses. And then we can actually create what we want in this class. So what we're going to do here is, I'm not going to do anything with this class. I'm just going to write pass. And in my car, I'm just going to create Mercedes. We're going to run the code again. And we can see that we got the same results, even though now we've used Mercedes instead of car. So that means that every method that is available to car is now also available to Mercedes. So what happens if I take all of this? You know what, let's just take specifically, let's take both drive and park and put it here, and also the init. So now just going to put it here, and only isDriving is going to remain in this class. You can see that it is for now it is non-existent. So let's see what it's going to do. Okay, so wait a second. I'm just going to comment this out and let's try again. So even though here self.driving doesn't exist in car, but because it's a class method, it exists here too and is related to anything else that is in this class. So when you actually use this piece of code, you get to use self.driving from Mercedes. Okay, that's important. It can be confusing, I know. If you have any questions about it, let me know in the comments below. But actually, a class method is actually something that you can use whenever. So this is the first thing that I wanted to show you, aside from also showing you inheritance, which is great, but also let's talk about static method. Static methods are something that you can use and are available without even using an instance, which means that when I use this method, it would be from car itself and not an instance of car. So let's define, and then what we want to do, we are going to print brand. Okay, and a static method doesn't have any arguments, we just follow by colon, and then we're going to print, and we're going to just say brand. And for now, what we can do is we can print, and I'm going to do this from Mercedes, print brand, because it's also available to the inheriting class. But you know what? Let's do it like this, Mercedes. So I'm not using the instance, I'm using the class itself. I'm not using my car, I'm using the class. So let's see what happens now. So I got none. No, I got brand. Okay, I get what I did here. I printed the print, and this method doesn't return anything. So this is what I should have done. Okay, and here we go. Now we have brand printed here, which was what we printed using this static method, which is also available to the inheriting class, Mercedes. Okay, the last thing that I'm not going to touch on, I just want to show you, is something called abstract method. Abstract method is a class that you just define, and let's call it virtual drive, and I'm just going to put this, which means that this class, this method is just kind of a method that exists, and it would also be available to Mercedes, but it doesn't have any implementation, and it is expected of Mercedes to actually implement this this method. It's kind of a contract, if you will. So I'm not going to dive into that. It's a fairly complex thing to touch on. If you want to know more about like abstract methods and generics and all of those kind of things, I can do a separate video about that, but I feel like for a beginner video, that is diving too deep for now. So this is what I wanted to show you about classes. We talked about inheritance, we talked about all of the things that are relating to methods and properties and stuff like that. So if you have any questions, let me know in the comments below, and then in the next lecture we are going to touch upon modules and packages, and we're going to talk about this thing right here that you've been seeing called PyProject.toml in my previous videos, and I didn't even mention what it is. So we're going to talk about all of that in the next lecture. So click right here to get to that lecture, and I'll see you there.